Hello everyone, welcome back to Mathematical Mindset. So right here we have this 9 square root algebra problem, and the question says the square root of 3 plus the square root of 64 plus 16 into the square root of 12 is equal to. We are to solve for this. So the first thing guys we want to do right here is to simplify the innermost roots. So simplify the inner roots. We have this to this point to be the inner root, so I'm just going to write this out. So I'm going to have this to be 64 plus 16 into the square root of 12, and we can easily rewrite this to be equal to the root of a plus the root of b by applying the property of nested radicals. Now we are applying the property of nested radicals because these innermost roots right here have a rational and irrational roots. Okay, so that's the main reason why we need to apply the property of nested radicals. So at this point, all we have to do is to simply square both sides. So squaring both sides, we have this to be, this is going to cancel out this, so we have 64 plus 16 into the root of 12 is equal to the root of a plus the root of b all square. Now, the root of a plus the root of b all square is given as a plus b plus 2 into the root of what? AB. So right here, the next thing we want to do is to simply compare. So by comparing the rational and the irrational parts, we have the rational and irrational parts right here. So we have the rational part to be 64 and the irrational part to be 16 root 12. So comparing the rational and irrational parts, we have this to be a plus b, which is the rational part for this, is equal to 64, and we have this to be 2 into the root of AB is equal to the irrational part of this, which is 16 the root of 12. Now from here, a plus b is rational, while 2 into the root of AB is the irrational part. So we want to simply equate the both of them. So we are going to call this equation 1 and call this also equation 2. So we are going to say from equation 2, we have this to be 2 into the root of AB is equals to 16 into the root of 12. So divide both sides by 2 to isolate the root of AB. We have that this is going to cancel out this, so we have the root of AB is equals to 2 here 1, 2 into 16 is 8, so we have 8 into the root of 12. So in order for us to have just AB, we want to square both sides. So this is going to cancel out this, so we have that AB is equals to 8 raised to the power of 2 multiply the root of 12 raised to the power of 2. We have that AB is equals to 8 raised to the power of 2 is 64, multiply, this is going to cancel out this, we have this to be 12. So AB is equals to 64 multiplied 12 is 768. So hence, we have the equation to be, now from the first part we already know that a plus b is equals to what? 64. So we have a plus b equals to 64, and we have that AB is equals to 768. So at this point, we want to simply solve for a and b by applying the sum and product of the roots of a quadratic equation. And we have the sum and product of a root of a quadratic equation to be given as x squared minus into a plus bx plus ab is equals to 0. So we have this to be x squared minus a plus b, we have it to be 64x plus AB, which is 768, and this is equals to 0. So we are going to solve this quadratic equation by applying the quadratic formula. So we have the quadratic formula to be given as x is equals to minus b plus minus the square root of b squared minus 4ac divide 2a, where we have that a is equals to 1, b is equals to negative 64, and c is equals to 768. So this becomes x is equals to minus into minus 64 plus minus the square root of b square, which is minus 64 all square, minus 4 multiply a, which is 1, multiply c, which is 768, divide 2 multiply a, which is 1. So we have that x is equals to minus times minus is plus, so we have 64 plus minus the square root of minus 64 squared is going to give us 4096 minus 4 multiply 1 4 multiply 768 will give us 3072 divide 2 multiply 1 is 2. So we have that x is equals to 64 plus minus the square root of 4096 minus 3072 will give us 1024 divide 2. So we have that x is equals to 64 plus minus the square root of 1024 is 32 divide what? 2. So we have that x is equals to 64 plus 32 over 2, and x is equals to 64 minus 32 over 2. So x is equal to 64 plus 32, we have this to be 96 divide 2, and x is equals to 64 minus 32, we have this to be 32 divide 2. So x is equals to 96 divide 2 is going to give us 48, and x is equals to 32 divided 2 is going to give us 16. So thus from here we have that a is equals to 48 and b is equals to 16. Okay, now I want to simply recall at the beginning that we have that the square root of 64 plus 16 into the root of 12 is equal to the root of a plus the root of b, right? So from here we want to say, recall, we have this to be the square root of 64 plus 16 into the root of 12 is equal to the root of a plus the root of b. So this is equal to the root of a is 48 plus the root of b, which is what? 16. And this is equal to the root of 48 can be expressed as 16 multiplied 3 plus the root of 16. This is equal to the root of 16 multiplied the root of 3 plus the root of 16. So this is equal to the root of 16 is 4, multiply the root of 3 plus the root of 16 also here is 4. So if you multiply this, we have this to be 4 roots of 3 plus what? 4. And this becomes the answer for the innermost root, which is 64 plus 16 into the root of 12. Now recall that we were solving for the innermost root because at the first part I said let's simplify the innermost root. Okay, so we have been able to simplify this. So the new equation is going to be, hence the new equation we have this to be the square root of 3 plus 4 root 3 plus 4. From the first solution, when simplifying the innermost root, we have the root of 64 plus 16 root 12 to be equal to 4 root 3 plus 4. So we have this right here. Okay, so we want to solve for this right here. Okay, so solving for this, we have this to be the square root of 3 plus 4 is going to give us 7 plus 4 root 3. So we can easily say that 7 plus 4 root 3, applying the property of nested radicals, we have this to be the root of a plus the root of b. So the next thing we want to do is to simply square both sides. So we have the square root of 7 plus 4 root 3 is equal to the root of a plus the root of b. So squaring both sides right here, we know that if we apply this property which says the root of a plus the root of b all square is equal to a plus b plus 2 into the root of ab. So we're going to apply this to the right hand side of the equation. So we have, this is going to cancel out this. We have 7 plus 4 root 3 is equal to, now the square root of a plus the square root of b all square is equal to a plus b plus 2 into the root of ab. So equating the rational and the irrational parts of this equation, we have that a plus b is equals to 7 and 2 into the root of ab, and this is equals to 4 root 3. So we're going to call this equation 1 and call this equation 2. So we say from equation 2, we have 2 roots of ab is equals to 4 root 3. So divide both sides by 2 to isolate the root of ab. So we have, this is going to cancel out this. So we have this to be the root of ab is equals to 2 here, 1, 2 into 4 is 2, 2 root 3. So square both sides to remove the square root. So this is going to cancel out this. We have that ab is equals to 2 raised to the power of 2, multiply the root of 3 or raised to the power of 2. ab is equals to 2 raised to the power of 2 is 4, multiply this, cancel out this, we have this to be 3. So we have that ab is equals to 12. So hence we already know that a plus b is equals to 7. So from here we have that a plus b is equals to 7 and ab is equals to 12. So applying the sum and product of the roots of a quadratic equation that says x squared minus into a plus bx plus ab is equals to 0, we have this to be x squared minus a plus b, we have it to be 7x plus ab is 12. So this is equals to 0. We want to factor out this. So if I take in this and multiply them, we have this to be 12x squared. So you think of a number that when you multiply those two numbers, it's going to give us plus 12x squared. And when you subtract those numbers, it's going to give us negative 7x. We have those numbers to be minus 4x and minus 3x. Minus 4x times minus 3x will give us 12x squared, and minus 4x minus 3x is minus 7x. So we have this to be x squared minus 4x minus 3x plus 12 is equals to 0. Factoring out x from this 2, we have that x is equals to x minus 4. So if you factor out the common term, we have this to be minus 3 into x minus 4, and this is equals to 0. So from here we have that x minus 4, x minus 3 is equals to 0. So x minus 4 is equals to 0, or x minus 3 is equals to 0. X is equals to 0 plus 4, and x is equals to 4. Or we have x is equals to 0 plus 3, and x is equals to 3. So from here we know that a is equals to 4 and b is equals to 3. Now I want to simply recall at the beginning that the square root of 7 plus 4 root 3 is equal to the root of a plus the root of b, right? So recalling that right here, we're going to say recall. We have that the square root of 7 plus 4 root 3 is equal to the root of a plus the root of b. So this is equal to the root of a, we have a to be 4, plus the root of b, which is 3. So hence we have that the square root of 7 plus 4 root 3 is equal to the root of 4 is 2 plus root 3, and this becomes the final answer. So right here guys, we have been able to solve this 9 square roots problem right here, and we have the final answer to be equal to 2 plus the root of 3. So with this guys, I'm going to see you in the next video, and if you are not yet subscribed to Mathematical Mindset, please do it to click onto that subscribe button, turn on your post notifications so that you get notified whenever I post a new video.